A sequence in which each term differs from its preceding term by a constant difference is called as arithmetic progression. Let us look at this pattern of tumblers. At the baseline, you have 7 tumblers. In the next row, you have 6 tumblers. And in the last, that is the top row, you have 5 tumblers. So look here. So the last row has 7, 6, 5 and so on. So the common difference here is negative of -1. Now let us look from the top row. Now at the top row you have 5 tumblers, at the base row you have 6 tumblers and at the least row you have 7 tumblers. Here the common difference is +1. So what are the terms we are using here? Here the common difference is represented by a symbol D. The first term is represented by a symbol A and the last term is represented by the symbol L, which is also called as AN. Now we have seen what is an arithmetic progression. Let's now see how to find the sum of n terms of arithmetic progression. This is a rectangle of length A and width 1 centimeter. This represents the area of A square units. The second strip represents the length A plus D unit and the breadth 1 unit. So the area is A plus D. So here you can see that the area of these rectangles are in arithmetic progression. So the first term is A, it goes on like this and the last term becomes L. So now what I am going to do is, I will now add all the areas from the first term to last term. So A plus D plus A plus 2D plus L. You know that addition is commutative. The value does not change. So what I am going to do again, I am now going to add the areas of this rectangle in reverse order. So that also will represent Sn. So now Sn is equal to L plus L minus D. It goes on till first term. So now we have two equations. Sn, the sum of n terms of these areas from A to L, and Sn from L to A. Now I am going to add these two equations. So what will happen? Now I will take the same rectangle of length L unit and breadth 1 unit. I am going to now add with the first term. Now I am going to add the last before term of length L minus D and width 1 unit. I am now going to add with the second term. Likewise, the process continues. So now you can see here I am adding all the areas. Now you can see a complete rectangle. The rectangle whose length and width are seen. Now here you can see that the first term, it becomes a rectangle of length A plus L. The width is 1 unit. Similarly, if you see this second term, here also what happens? L minus D plus A plus D is again A plus L. So the process continues. Let's now look at the last before term. A plus D plus L minus D is again A plus L. The last term is also A plus L. So this is a rectangle of length A plus L and the breadth of each area is 1 unit. So it extends to n units. So this is a rectangle whose length is A plus L and the breadth is n. So the area of this rectangle is A plus L into n. So the sum of the terms from the first term to the last term and the same sum in reverse order is nothing but the area of the rectangle. So 2Sn is equal to A plus L plus A plus L plus A plus L till A plus L. So it can be rewritten as 2Sn is equal to n times A plus L. As you know that repeated addition is multiplication. So 2Sn is equal to n into A plus L or Sn is equal to n by 2 into A plus L. Therefore, the sum of n terms of arithmetic progression is derived as Sn is equal to n by 2 into a plus l, where n represents the number of terms, a represents the first term and l represents the last term. So, using this equation, you can derive the sum of n terms of any AP. So, students will be able to substitute n of different values for the AP whose first term differs and the last term also differs.